The Lancia Delta is back from paint and ready for us to start putting it back together.
Before we get started, we're going to put the car up in the air and take you through some of the fabrication work that we carried out before the car went to paint.
In the last episode, we stripped down the Lancia so that we could carry out some rust repairs to the underside of the car. With the car back from paint, we got it straight back on the ramp so we could start putting it back together.
Up at the front, it's not been painted yet. This is because we mounted the spit here, so we were unable to access the front panel to prep and paint it. So once we get the car rolling again, we'll get it back around to paint and have this front panel finished off. Into the engine bay, we've removed absolutely everything from here to clear it out. We've also removed all the soundproofing material from the bulkhead to make it a lot lighter and a lot cleaner. We've removed any excess welds. We've redone some welds that weren't very structural or were just very ugly up the top. So we've got all that re-welded and then we've given it a full repaint in here. The sump guard brackets, we've ground away the welds that were there before. As we were grinding those away, they just fell off, showing that they had no penetration into the plate itself, so offered no structural benefit whatsoever. So we've re-welded those with proper penetration, now much stronger and much neater. The whole floor pan and the wheel arches before were showing signs of surface rust. So we've ground all of the paint back to the metal, and as we were taking the original sealant off, it was apparent that the two pieces of metal for the floor pan were no longer welded together. They were just floppy. Only sealant was holding them together, which is not safe at all. We've had that fully re-welded down both sides and then repainted. The rear suspension mounts, we've added skid plates. So if we take any impact to the rear suspension, it's not going to hit directly on the mount. It's going to deflect off instead via the skid plate and save the rear suspension from a direct impact. Skid plates also offer some strengthening to the original mounts as it prevents any flex from the rear edge. The anti-roll bar mounts, they've been totally removed as they were just riv nuts before, which didn't offer any structural benefit. We've welded in these tapped plates instead that are now welded directly to the chassis, and they're a much stronger basis for the roll bar to be mounted to. The rear section here was all twisted before, where it had been towed out of a ditch, and the whole rear chassis was a completely twisted piece of metal. The only way we could get that back was to simply cut it out and start again with a fresh piece of box section, which has been shaped back to the original form, and it's put the tow hook directly back in the correct position to come through the original bumper and offer a lot more strength than before. We did want to brace originally, but due to clearance issues, that wasn't an option anymore, so we've had to just simply replace the original rear section.
With the welding and paint repairs completed, we can move on to the next stage of the build, the wiring.
One of the first major issues we saw when taking this car back to pieces was the wiring loom. It looked like A, a fire hazard, and B, an absolute rat's nest. So we pulled it out of the car, and we got Darren down from DTO Motorsport, and he's going to run us through now some of the major issues that we found with this wiring loom.
I mean, when I first saw the wiring loom, I'm amazed that the car didn't actually catch fire. Some of the things that have been done. So basically, it's a standard Lancia road car wiring loom, and somebody's modified it, cutting into various parts of the loom. The fuel pumps weren't even on a fuse, they were just straight to the auto-elect via a relay.
And we found this, didn't we, this open-ended wires taped up.
Yeah, this was pushed into a metal cavity. It's part of the dash wiring for the original dash, as the car's fitted with a digital dash 2. So, you know, again, that's a massive fire hazard, you know, or alternatively, best case scenario was causing a unreliability, causing fuses to fail, etc.
Yeah, exactly. And the list went on, didn't it? So a lot of these wires as well aren't needed, so it's excess weight that we don't need, and it's just potential unreliability that we can remove from the car if we just get rid of the whole loom. I
mean, in this, we've got heated rear windscreens, we've got door sensors for putting indications on dashboards for the door being open or not closed properly. We've got stereo wiring, we've got everything you just don't need in a competition car.
Yep, exactly. And after a good look and a few anomalies that we found, the best solution is going to be just totally remake the loom from scratch, and we're fully in control of the loom from that point forward.
Yeah, absolutely. And there's a large weight saving in that as well. You know, you're probably going to find at the end of it, we've saved upwards of 15 kilos.
Yeah, it's huge saving from wires as well.
Yeah,
such an easy way to
and,
save some weight.
And massive reliability, improvement for the car.
Yeah,
the car is going to be used as a competition car.
Exactly, and we can blueprint the loom as well, can't we? So issues could be traced in the future quite quickly.
Yeah, the whole point of replacing this loom and building a bespoke loom is we'll be able to tell you what every pin on every plug does, where it goes, etc. We're going to build a complete new fuse box, relays. It's just going to be accessible. It's just going to make the vehicle reliable, and it's also going to look a lot better.
Fantastic. All right, let's get cracking.
The new wiring loom will provide a solid foundation to the car. Often overlooked, it will prevent future headaches by not having to hunt out electrical issues. The first stage is to dissect the remaining wiring and plan what the replacement loom will need to have. In the process of doing this, Darren found a number of things that had been wired incorrectly.
What happens with the ECU is you have a fuel pump relay, and the ECU actually sends a ground signal down to that relay to engage the relay when it's ignited. What it does is it puts a measured amount of, it runs for a certain amount of time, producing fuel pressure, which gives you enough to crank the car and start the engine. Once it receives a crank signal to the ECU, it then brings the relay in permanently. So that keeps the fuel pump running, providing fuel to the engine. If for any reason that crank signal's lost, it then turns the fuel pump relay off. This means obviously it stops the fuel pump from running, which obviously in an incident, that means you haven't got high pressure fuel running through the vehicle. Now, from what I could tell when we pulled the original loom apart, that system wasn't in place and wasn't working. So if the vehicle had been involved in an incident or something had gone wrong, we would have had high pressure fuel running all the time until the actual power, the master power, was switched off on the master auto elect. So to me, that's, well, to anybody, that's not the way to do it.
As well as ensuring that things are wired correctly, detailed diagrams are drawn up for future reference. It's also a great opportunity to improve upon the existing layout of the wiring. Fuse boxes and relays can be relocated for easier access, and extra components such as a backup fuel pump can be wired in.
Initially, when we started to strip the car down to work out what was required to keep the original column switches in their working order, and the original switches, as a rule, we found that there was a lot of wires that had been broken into to create a separate circuit. Again, there was, I think we counted upwards of 20 relays on the vehicle for some unknown reason, all hidden and zip tied to the actual structure of the dashboard rather than being in a relay holder. So if you had any issues or anything with the vehicle, you wouldn't be able to get to that easily and replace a faulty relay or deal with any issues. So what we've done with Matt is simplify everything, because before we had switches here, it was all over the place. So what we've actually done now, unfortunately the panel's not in yet, but we've got all the driver's information gauges here. So we've got boost pressure, fuel pressure, oil pressure, etc. It's all up here. Then what we have down here, we have it nice and simple. We've got a horn, we've got the demisting fan, we've got the rain light, fog light, and then when the vehicle eventually does get a spot lamp pod, we've got a fog lamp, spot lamp switch there, so you can drive with or without spots. Again, you've got master switch. This is what we call the main life support. It's the master switch, ignition. We've got the fuel pumps. We've got 3 stages. We've got fuel pump 1, fuel pump 2, and then obviously the start button. We're going to have fire extinguisher control. The fire extinguisher control box will be up here. It's just simplifying the layout for the customer and making it a more reliable composition vehicle.
To make the car easier to move around the workshop, we refitted the suspension and wheels. With the wiring completed to a certain point, the engine and other components need to go back into the car before any more progress can be made with the wiring. While Darren had been busy wiring, he'd given us plenty of time to give all the parts a thorough inspection and service before they went back on the car. The engine was fresh back from a rebuild, and with the car's small engine bay, we used a combination of the ramp and engine crane to lift it into place through the bottom of the car. The car is slowly starting to come together. By the time it comes to the next instalment, she'll be ready for it to start up.